Hello, Eastview Scholars, and welcome to this edition of Sharp Shorts, where we're going to talk about one of the key concepts in chemistry, and that's the mole. And although we are past that at the time of this recording, remember Mole Day is always October 23rd, starting at 6:02. Make sure you have a fun time and a party, and have some molasses cookies, and enjoy science. Anyhow. Let's talk about what this is first. Really, the mole is a counting thing. If you wanted to enjoy your Italian, really also I want to point out this is Avogadro, Italian scientist who figured out how to count atoms, because that's our issue. Is atoms are so small, how do we get it to a point where we can use it in the lab? And that was Avogadro, and his theory basically just working with gases, which are very linear and mathematical, said that if you had equal volumes of gases at the same temperature and pressure, then they would contain the same number of particles. Really, it came down to this. Okay. Let's line this up a little bit. A mole is a counting thing. It is, you ask somebody how many is in a dozen, everybody knows it's 12. Well, that's the same thing as a mole. It gives you something to organize all the atoms and stuff for. We measure stuff in the lab in grams on a scale, or even pounds or whatever you would want, but you don't get that whole number ratio that Dalton talked about that you can write chemical equations for and stuff to understand what it is. So a mole of anything contains Avogadro's number, and here it is, 6.02 times 10 to the 23rd, which is why Mole Day is October 23rd, starting at 6:02. But as you can see by all these examples, all that's trying to show you is whether it doesn't matter what you're counting. If you have this number, you have 1 mole of that stuff. The other key is that if you look at the atomic mass of an element, like carbon is 12. If you look at carbon, number 6 on the periodic table, and you look at its molar mass, it's 12 point blah, 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 blah. That atomic mass is also the mass of 1 mole. And so we call that the molar mass, really, is another term for this, or some folks call it the Graham formula mass. Either way, I'm a molar mass kind of guy. Anyhow, that tells you exactly how much mass is in 1 mole. And then when you use a chemical equation, as we'll see later, then you can see the relationships of how many atoms of this work with how many atoms of that in compounds and everything else, and that mole ratio holds for your predictions. Anyhow, this is the best thing to know in this flow chart. This is all we're talking about. The mole is our bridge between the atomic world and the world of mass in grams. It's always calculated in grams. And so really, all you're doing is, if you want to understand how many particles or what's going on in your chemical reaction, and can you predict how much product will be made and everything else, you need this mole bridge with the chemical equation to help you along. But it's really quite simple. There are this many particles in 1 mole, so if I knew my mole number, I could multiply by Avogadro's number, and I would find out how many particles that is. And particle is a word that goes with atom, compound, molecule, whatever you want to use in chemistry. Anything that is not talking about mass is a particle. Bagels and donuts and whatever. If I knew how many atoms or molecules I had, and I wanted to figure out how many moles that is, then I would divide by our Avogadro's number. Okay? If I know the moles, then I can easily convert into mass, which is something I can do in the lab. And this portion of the flow chart is really what we spend most of our year using. Okay, so anyhow, if I know how many moles, I can figure out the mass of that many moles by just multiplying by the molar mass, or atomic mass, whatever you want to call it. If I know the mass, then I can figure out how many moles by dividing by the molar mass. Now, a few rules in following these as we do problem examples in a second. Just read the problem. Know what number you start with. So where am I starting on this chart? Know where I want to end. So where am I going to? And then follow the arrows and let it tell you what the math will be. Okay? In this class, in our class, for simplicity, we're going to round all the elements to whole numbers except chlorine. We're going to keep that at 35.5 because chlorine is one of those, what's called a diatomic element. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. You often see like oxygen. You also always see it written O2 if it's not part of a compound. Okay, same as the nitrogen in our atmosphere. Those 7 elements are just for stability. They pair up when they're not as part of a compound, when they're only by themselves, like these 2 in the atmosphere. They pair up. And so what that's going to do is change their molar mass, because their molar mass is going to be double what it says on the periodic table. And here for compounds, if I want to know the molar mass of a compound, I just add up the molar masses of all the individual particles and how many I got. So in this calcium nitrate, I have 1 calcium. I have 2 nitrogens because I have 2 of this nitrate mess in this parentheses, so there's 2 nitrogens. And there's 3 times 2 is 6 oxygen. That's 40. Each of those are 14. Each of those are 16. When I add that up, it becomes 164. And really, in the reality, in doing these problems, there's 2 mistakes. Often folks will multiply or divide when they're supposed to do the other. So if they're going from mole to particle, they'll make the error of dividing instead of multiplying. Or if they're going from particle to mole, they'll do that same math there. The other thing, as Mr. Meyer is often good at saying, is they'll make a dumb mass mistake, in which they'll forget to add up all the masses of everything in there and all the particles. Anyhow, let's go to a couple examples and see how it works. Here's our flow chart. Here's our problems, and this is all it is. How many atoms are in 1.25 moles? Notice I didn't even tell you what it was, because from this bridge to this bridge, it doesn't really matter. It doesn't matter what it is, because I'm just trying to determine moles and particles. So the math would just be then simply I'm starting at 1.25 moles, which is right here, and I'm going to particles. So I multiply by 6.02 times 10 to the 23rd. My writing is a little goofy today. Come on, stylus. And if I do that math, it comes out to be 7.5. Actually 7.53, because we started with 3 significant digits, times 10 to the 23rd. So that's how many atoms would be 1.25 moles. Now, the next problem says how many molecules in 1.25 moles. Well, notice that I'm going for moles and I'm heading to particles. I'm doing the same exact thing I did here. I would have the same exact answer. And part of the reason I did that was to illustrate the fact that between moles and particles, it doesn't matter what it is, because you're only using Avogadro's number. Okay. Now, our next problem says how many moles in 35 grams of calcium. I'm starting here, and I'm ending at moles, so I'm going to divide by the molar mass. So I'm going to start at 35 grams. And I'm going to divide by the molar mass of calcium. And if I look on the periodic table and I round it to the nearest whole number, it's 40 grams per mole. When I do that division, then I'll find out that 35 grams of calcium is equal to 0.875 moles. Again, I apologize, the stylus is doing its own thing right now. Okay. It seems very simplistic, just follow the flow chart, but that is, and this combination here is one of the key components that you have to know in chemistry. So if you can do this, you're fine. Okay, now, how many grams, so I'm going to finish at grams, in 4.5 times 10 to the 26 molecules of water. So I'm starting here, and I first have to go to the mole, and that'll be my first jump. So I'm going to divide by Avogadro's number. Once I get that answer, then I'm going to go to mass, and I'm going to multiply by the molar mass. So the first thing is to take the 4.50 times 10 to the 26. And I'm going to divide by 6.02 times 10 to the 23rd. Okay. And that's going to give me a number quickly. Sorry. Let's do this here. 748 moles. Okay. Now my next job is to take that and multiply by the molar mass of water. Water is H2O. Each hydrogen is 1, oxygen is 16. So I've got 1 plus 1 plus 16 is 18 grams per mole. That's the molar mass. So I'm going to multiply that by 18. Come on, stylus. And I'm going to get about 13,500. It comes out to be 13,464. We had 3 significant figures. So we are going to call that 13,500 grams. So that's it. That's our work with the mole. Just know the flow chart. And again, the ruling. Just trying to keep things consistent, rounding things to the nearest whole number. We don't have to worry about isotope percentages or everything else. Don't forget your diatomic elements are adding up your masses correctly. But if you can do that and understand that, you should have no problem solving mole to mass conversions or mole to particle conversions. Either way, have a good day, and Scholar up, Eastview.